In this video, we're going to discuss how to calculate measures of relative standing using z-score. All right. So in this example, we're going to be using the z-score to compare two different data sets. All right. So let's remember the equation for a z-score. I mentioned it briefly in the Chebyshev's theorem. One of the examples using Chebyshev's theorem, though let me go ahead and mention the formula for it again. So a z-score is basically the number of standard deviations away from the mean. Okay, so for a sample, the z-score is x minus x bar divided by the sample standard deviation s. Okay, so the difference from the mean divided by the standard deviation. Okay, so for a population, it's the same equation, just replace the sample mean with the population mean, mu, and the sample standard deviation with the population standard deviation, sigma. Okay, so you can calculate z-scores for populations or for samples. All right, so let's go ahead and read through this question and get a little more familiar with using z-scores. So Sarah earned a 85% on her math test. The average for Sarah's class, or Sarah's test, was 75%, and the standard deviation was 15%. All right, so first let's think about Sarah before we go on to Mary, Sarah's sister. Okay, so so Sarah earned the 85%, right? So she earned the 85, and the 75% is actually that's actually the population mean for Sarah, right? So mu is 75. Okay, 75% or 75. It doesn't matter actually if I write this as 0.85 and 0.75, just as long as I'm being consistent. If I want to just leave it as 85 and 75, that's okay. So let's see. It's mu, and it's the population mean, because it's not like they only did they only sampled some of the students and took their sample average from, no, the entire class took the test, right? So that's why it's mu and not x bar. All right, so the population took the test. Okay, so the population in this situation is Sarah's class. All right, and the standard deviation, sigma, is 15. Okay, 15%. All right, so now let's go ahead and read up about Mary. So Mary, which is Sarah's sister, she earned a 83%. Okay, 83. And the class average for Mary, so again, that would be mu, because it's the entire class who took the test, not just a random sample of some of the students, right, is 70%. And the standard deviation for Mary is 10%. Okay, so who did better on the test relative to their class? So that's what a z-score is going to calculate. It's going to calculate the number of standard deviations that each of these students performed compared to their class, right? So for z-scores, we don't have to assume that it's normally distributed, that the distribution of the class is normally distributed. But let me just draw the distribution that looks. I'm just going to draw the distribution looking kind of like a bell shape, but it could be anything, right? The distribution of test scores could be anything. All right, so here in the center, though, is 75. And then Sarah scored an 85. So what we want to know is how many standard deviations away from the center is her score, this 85%. Okay. All right, so to calculate that, let me go ahead and scroll down a little bit. We'll calculate z, which will be x minus mu divided by sigma. So x in this case is Sarah's score, which is 85 minus 75 divided by sigma, which is 15. Okay, so that's 10 divided by 15 So that is 0.67. So Sarah scored 0.67 standard deviations higher than the mean. Okay, Sarah's score. All right, so now let's think about Mary's score. Okay, so here's Mary's distribution. You know, again, it could look like anything. And here in the center is the average, so average of 70, and Mary got a 83. All right, so Mary got an 83. All right, so let's go ahead and calculate the z-score for Mary. Okay, so it's still going to be x minus mu divided by sigma. So that will be 83 minus mu, which is 70, divided by the standard deviation, which is 10. So that'll be 13 divided by 10, which is 1.3. So Mary did 1.3 standard deviations higher than the mean. So relative to her class, she did better, right? The number of standard deviations that she was away from the mean, first off, you'd want it to be positive, right? So you did better than the average person in the class, and Mary did much better. She did 1.3 standard deviations above the mean versus Mary, who was only 0.67 standard deviations above the mean in her class. Okay, so who did better relative to their class? Mary. Mary did better relative to her class.